Hello, my dear students, and welcome in the Indoor Environmental Control course. I am Associate Professor Kareem Galal.
This time I will explain the daylighting simulation and auditing methods. The title of this lecture is Daylight Models. In this lecture we will discuss the tools that help us to take the design decisions concerning daylighting. Also audit the existing space to evaluate the daylighting performance. For more complex geometries and unusual situations, the most reliable way of prediction of daylighting is by the use of physical models. The model should not be too small. A scale of 120 is often used, and it is important that internal surface reflectances should match realities as near as possible. Artificial sky simulators have been developed to simulate overcast sky conditions. The hemispherical skies can be of three types. First type is hemispherical translucent diffuser, inside of a structural dome, with the lighting installed behind it. It is called a backlit translucent artificial sky. One of this type exists in the Bartenbach Academy. Researchers can take measurements by using hand lighting intensity meters. Read and record the results. Take a thermal imaging shots using thermal cameras. The second type is an opaque dome, with a diffusely reflecting internal surface, with the lighting installation below, lighting upwards, all around an annular space. It is called a reflective solid artificial sky. One of this type exists in City University of Hong Kong. The third one is the rectangular, mirror-type artificial sky. Consists of 4 walls lined with mirrors from table height up to the ceiling. The ceiling is made of a translucent diffusing material, with the lighting installation behind it. It is called a mirror-type artificial sky. One of this type exists in the artificial sky at Department of Architecture and Industrial Design Luigi Vanvitelli. But these types of equipment are very expensive and cannot exist in all universities, especially for the undergraduate students and even in sometimes in research centers. We use for this case the Sundial Charts method. It is based on the natural sunlight, physical model for the building, sundial for a specific latitude, light intensity measurement tools, or camera. The sundial is classified according to the city location, referring to the latitude degree for the city. It contains 7 curved lines indicate the months. Radial lines indicate the time of the day. South direction. Cut off triangle. The place to paste the triangle base. To use it, you should cut the triangle and bend it from the mid-dashed line. Then paste its base on the dashed lines on the chart to make sun track of the sundial. Paste the sundial chart on the physical model base according to the south orientation of the model. Move and direct the model to let the triangle shadow sign to a specific time on the chart lines, such as May at 10 o'clock. The shadow of the model and the indoor lighting represents the typical state at this time in the year. But wait, what is about the complicated model forms and spaces? There are different digital simulation tools to study these cases, such as Velux Daylighting Visualizer, which is a simple software for undergraduate students, and Design Builder software, which is an accurate software for researchers. But what is the daylighting decision tool for the already existing spaces? There are many tools such as light intensity, humidity, and temperature data logger, light intensity meter, hand tool, indoor data logger station, occupancy data logger. Thanks for following me, and I hope that I have explained the topic well.
This material is copyrighted Associate Professor Kareem Galal 2021. All rights reserved.